Hey, hello guys, welcome, Vandanam, Namaskaram. Today we are going to see differentiation. So already you would have seen continuity and now we are in differentiation. Maybe you would have seen differentiability also, or maybe you wouldn't have because I've not yet taken the video of differentiability. But differentiability is like the basics for differentiation, but there isn't that much connection between differentiability and differentiation. Okay, so before get going into this lesson, we have to know some formulas which are very important. Okay, so the first formula, which is this one second, so dark green here we will take. Okay, so first formula is differentiation of a constant. Okay, by the way, if you have seen differentiability, then you would have known by what notation we will be representing differentiation. It is represented by d by dx. Okay, so d by dx of a constant is the first thing. Okay, k represents always constant. Okay, which is equal to k. Okay, but it need not be just k. See, constant means what? It can be 1, it can be 2, it can be then what else it can be? It can be log 2. Okay, even in question they can say that a is a constant, b is a constant. So if they are saying like that, then in that sense a is a constant, then b is a constant, then k is a constant. Like this, they will be giving you something. Okay, not really log 2, log 3, any value of log. Okay, any value, any positive value. Okay, so log of x, where x should be given. If it is log x now, then it means different. Okay, but inside here, okay, inside this log, if there is a constant, then also it is constant only. Okay, so this is your first differentiation rule. Then the second differentiation rule is actually d by dx of constant into a variable. Okay, so we can keep it as k. Okay, no, we will see that. Okay, now even I will say, so constant into that variable, it can be x to the power of n. Okay, so how will be this one? See, when you're differentiating it, okay, before this I will say to you all the differentiation of, this is actually a theorem. In that theorem we will be discussing it. So now we will be coming to this. Oh god, d by dx of x to the power of n. Okay, so this one will be equal to n into x to the power of n minus 1. So that means, for an example, there is x to the power of 5. Then you have to differentiate. Okay, the differentiated value of x to the power of 5 is 5x to the power of 4. Okay, it's 5x to the power of 4. Then next, after this, we have e. This is actually very famous. It is d by dx of e to the power x. Okay, even some memes are there. Okay, because e to the power of x cannot at all be changed. Okay, so this is equal to e to the power of x itself. Okay, then we are having like this. Okay, d by dx of a to the power of x. Okay, see, what is e? Okay, so what is e? E is Euler's constant. E is Euler's constant, whose value is 2.187, which we have discussed very clearly in our relations and functions in that logarithmic. I've given you a lot of identities for logarithms, then I've given you what is a logarithmic function, then I've given you the graph, everything. Okay, there we have discussed about this, and also I said over there even why did they take e, why not any other value? One of that reason is this one, because the differentiation of e to the power of x is e to the power of x itself. And now you might ask me a question. This is a constant, right? Okay, this is a constant, right? Then how come it is not equal to 0? When we are differentiating it, how come it is not equal to 0? Okay, well, the answer is, that is what the speciality is. Okay, that is what the speciality of e to the power of x. Okay, then a to the power of x. Okay, see, x to the power of n is different and a to the power of x is different. Here n is a constant. Okay, here n is a constant, but x is a variable. Here a is a constant. Okay, here a is a constant, but x is not. Okay, but x is a variable. Okay, so for this, how will you differentiate it? You can say it as a to the power of x into natural logarithm. Okay, which is natural logarithm means the base is e. That's it. That's what the difference between common logarithm and the natural logarithm into a. Okay, sorry, this is what, not into natural logarithm of a. Okay, where a is a constant. Then if they have given you like this, which is d by dx of log x, okay, of log x is equal to 1 by x. Okay, not only x, it can be anything. Okay, it can be anything other than a constant. Okay, for an example, if they have given you logarithm of 2x square plus 5, then the differentiation of this will be is equal to 1 by 2x 5 plus, sorry, 2, this is 2 now. Okay, 2 plus 5, and again you have to differentiate this one, that we will be seeing later on. Okay, but if you have to differentiate it now itself, then it will be 4x. Okay, then it will be 4x. If you have to, now in chain rule we will be discussing about this very clearly, don't worry. Okay, then after this, what else do you have? So logarithm I have said now, and yeah, this is actually modulus. Okay, always the input for a logarithm should be positive. This also we have discussed in relations and functions. If you don't know about logarithm, then go and watch relations and functions from the scratch to the matchbox we have discussed. Okay, it's not matchbox to the woodlog we have discussed, we can say like that. Okay, so d by dx of, now what shall we take? Discussed. You are having something like this log you are having, which is actually, okay, if I say this, I have no problem, but here to the base e, okay, you keep it as to the base e, then it is okay, which means it is actually natural logarithm. But when some other base, okay, when some other base a or b or like that, means here base e is 2.7 something, right? 2.17, sorry, 2.718, like that something, right? Okay, but I said first 2.17, now that is wrong, 2.71. Okay, but whenever here like base 10 is given, for an example, you can take, or don't even take base 10, you take base value as 3, 10 also okay, 4, 5, 6, like this, anything is given, but remember a cannot be equal to 1. A cannot be equal to 1. This is also we have discussed here. Okay, so in that case, the value is going to be is equal to 1 by, okay, the input, I forgot the input. What can be the input? Let us keep the input as k. Okay, modulus k. Here also it cannot be negative. So the input is, so this is equal to k into natural logarithm of a. Okay, k into natural logarithm of a. So here comes our very famous trigonometric, okay, trigonometric differentiation and inverse trigonometric differentiations. So first one is going to be d by dx. Okay, so d by dx of cos theta. Cos x, it can be, cos y it can be, that's not a problem. In parametric differentiation we'll be discussing about this also. So this is d by dx cos theta, so it will be turned into minus, okay, it will be turned into minus sin theta. So wait, d by dx, okay, so d by dx of sin theta is equal to plus cos theta. Okay, so then one second. So then after this, what are the trigonometric values that you are having? You are having tan. Okay, so tan theta you are having, then cot theta you are having, then sec theta you are having, then cosec theta you are having, then inverse trigonometric values will be going. Before that we have some other values. No, only trigonometric is there. Then inverse trigonometry, then we will go to the next page. Next slide, in the next slide we will be using along with derivation of them. Okay, derivations also we will see. Blue color, na? Blue color, yes. So first is so tan theta. Tan theta is going to be positive sec square theta. Okay, then cot theta is going to be minus cosec square theta. Okay, then sec theta is actually plus tan theta into sec theta itself. Okay, for cosec and for sec, this is speciality. Sec theta into tan theta. The thing is, it is possible, that alone you have to note. Here it is going to be negative cot theta into cosec theta. Okay, cot theta into cosec theta. Okay, so minus cot theta into cosec theta. Okay, okay, so now we are going to inverse trigonometric functions. Not inverse trigonometric functions, sorry. That is ITF, we have already covered that. Now we are going to see inverse trigonometric derivatives, which is one of the most favorite topics for NTA. For NTA, the derivatives which are based on inverse trigonometric concepts is very favorite. Okay, they will be asking at least one question. So, what did I say? What was the name of that examination? Did I say NTA? NTA. So ITF derivatives. So d by dx, no, this is not neat. D by dx. Oh wait, I said we will be also seeing derivatives now. Okay, so first concept that we are going to discuss is sine inverse. Okay, sine inverse x. So what is this sine inverse x? What's the derivative of the sine inverse x? Okay, so we can take that sine inverse x. Okay, so sine inverse x is equal to y. Let it be. Now multiply with sine function, then it will be x is equal to sine y, right? Okay, so x is equal to sine y. One second. There are still lot of concepts that we have to cover before this, but first I'm giving you all the formulas, all the theorems, then we will be moving to sums. Okay, each and every sum will be moving. Okay, not every derivative we are going to see, 2 derivatives we will see, then other than that I will give you the formulas, and also I will be giving you the idea how to do them, then you can do it by yourself. Okay. Okay, now what you have to do is, now you have to differentiate it. So when you differentiate it, by the way, the differentiation of, okay, so d by dx of x and root x I have to write. Okay, so here I will write d by dx of root x is equal to 1 by 2 root x. 1 by 2 root x, and this is going to be what? What did I come to write here? X. Okay, is equal to 1. Many of you guys even will know the reason. If you don't know, if you know, then comment in the comment section. If you don't know, then you can write it in the comment section. Okay, so y is equal to x is equal to sine y. Okay, so now differentiate it. So it will be x's differentiation is going to be 1 is equal to sine is going to be cos y into, for y it is going to be dy by dx. Okay, so see, actually this is actually in chain rule concept. Where first is x. Okay, so what is the theorem? Let me see. This theorem we saw, right? So x to the power of 1. So then that means while you are differentiating it, dx, actually you can say like it has got cancelled, like that also it's okay. But if you want another reason, then this one you bring it front. Okay, so 1x, okay, 1 into x, 1 minus 1, which is going to be 1 into x to the power of 0, which is equal to 1. Okay, so here you got 1 and cos y into dy by dx. Okay, so this one you got right. Now what you are going to do is bring it over here. So 1 by cos y is equal to dy by dx. Okay, so what is cos y? The relation between cos y and sin y is what that you have to write here. So 1 by 1 minus 1 minus sin square y is equal to dy by dx. So what is sin square y? Sin square y is equal to x, right? So 1 by 1 minus x square root over, that is what I was checking, root over x square is equal to dy by dx. So what is y? Y in place of y you can write this one, okay, which is, so at last you have got the majestic formula, that is d of sine inverse x by dx is equal to 1 by root over 1 minus x square. Okay, 1 minus x square. So something we left up. What is this and where will it come? Oh, sine, yeah, I. Okay, so next is for cos we will see. Okay, so for cos we will see, so d by dx of cos inverse y. Okay, cos inverse x. So what is this? See, first you are going to keep cos inverse x is equal to y. Okay, so cos inverse x is equal to y. So x is equal to cos y. Okay, so now you are going to differentiate it, which is going to be 1 is equal to minus sine x. Okay, minus sine x. Sorry, minus sine y into dy by dx. Okay, so you can transpose this to here. So if you are transposing it, then it will be minus 1 by sine y is equal to dy by dx. So what is the relationship between sine y and what is that? Cos y. Sorry, yeah, sine y and cos y. You have to change it in terms of cos y. So then that means you can write it here as minus 1 by root over 1 minus cos square. Okay, you can write it as, yeah, cos square y. You can write it as cos square y, where cos square y is equal to x square. Okay, cos, if you are putting square y, here also square will come, right? Okay, so x square is equal to dy by dx. Okay, so then what is the value of y? Y is equal to cos inverse x. Cos inverse x. Okay, so now how will you do remaining formulas? Okay, very simple. First, what you are going to do, I'm just now saying the idea. Many of you guys would have got the idea already. If you have got, then skip 10 to 20 seconds. Okay, so d by dx of some trigonometric value take. So it can be any trigonometric value. So ITF. First, what you are going to do, you are going to equate that to y. Okay, that ITF value should be equated to y. So ITF should be equated to y. Then what you have to do, then you have to differentiate it. This is constant. Okay, this process is constant for every inverse trigonometric value. Okay, then after that, what you have to do, you have to differentiate it. After differentiation, then bring in terms of dy by dx. Okay, in terms. Then change this value to the other trigonometric value. Change to the other trigonometric value. Okay, like this only. Similarly, for other inverse trigonometric also it will be there. You can do it for that also. Okay, so this is how you have to do. Okay, further, those three golden important principal identities are important. What are they? Like saying one, sine square x plus cos square x is equal to y, then tan square x plus 1 is equal to sec square x, then cot square x plus 1 is equal to cosec square x. Okay, I said everything. By the way, that doesn't matter. Okay, but all these are important. Okay, so I will erase this. and I'll write remaining other formulas. Okay, and this one in pink color I'll write because that is what here I have written, right? So because of that, okay, so d cos inverse of x by dx is equal to minus 1 by root over 1 minus x square. Okay, 1 minus x square. The one and only difference here and here is here plus is there, here minus is there. That's it. Okay, so d by dx of what are the things that you are going to get? Remaining two, remaining four are there, na? Four. Okay, so 4 to 6. Totally 6. Okay, so first, but not the but wait. Okay, so first is d by dx. So of d by dx of tan. Okay, so tan inverse x is equal to, note this one point, that is for every inverse trigonometric formula's derivatives there will be this root. Okay, this root will be there, that is compulsory, except for tan and cot. Okay, 1 by, okay, so 1 plus x square. Okay, 1 plus x square. Then it is going to be for cot inverse. Cot inverse x is equal to minus 1 by, okay, so minus 1 by 1 plus x square. Okay, then for sec inverse x, it is going to be plus 1 by x root over x square minus 1. Okay, here this x is going to be modulus. Okay, this x is modulus. Then next is cosec. Is equal to, here minus should be coming, which is modulus of x root over x square minus 1. Okay, so yeah, and one point that I have to give you now in terms of like a mnemonics thing, and remember everything is in their respective domain. Don't ask me what is the domain. In relations and functions we have discussed, in ITF we have discussed very clearly. So yeah, for their respective domain they have to be, and also one shortcut is that, first what did I say? First I said that for tan and cot alone they don't be root. Okay, that is first thing that you have to remember. Then secondly, any inverse trigonometric value that is starting with co, okay, that is starting with co, cosec, cot, cos, okay, that will be having minus sign. Okay, minus sign in it. And thirdly, in order to remember all these, I gave you one expression in the beginning, not in the beginning in sense, when did I give you? Till now I have not given you. Okay, see, if you are getting a question like x square minus a square, then a square minus x square, then x square plus a square, then x minus, then a minus x divided by a plus x. Okay, or even root over x square minus a square, then root over a square minus x square, then root over x square plus a square, then root over a minus x whole divided by a plus x. For all these, okay, so for all these you can see in place of this, okay, in place of x, when you are having something like this, then in place of x you can substitute. In ITF I have written but I have not discussed about it. Okay, so in place of x you can write here sec, okay, a sec. Okay, so in place of x you can write a sec theta or a cosec theta. Okay, Then here in place of x you can write as a sin theta or a cos theta. Then here in place of x you can write a tan theta or a cot theta. Then here in place of x you can write either, here only one thing, that is going to be a cos theta. Mostly cos theta when this a is equal to 1. Okay, when this a is equal to 1, then you will be using a formula of tan of pi by 4 plus x. Okay, minus x, and when here a is equal to 1 and x is equal to tan square theta, okay, then you will be using in place of this total form, okay, in place of this total form you have to put cos 2 theta, okay, cos 2 theta. Okay, like for this you have to put cos 2 theta under these two criteria. If it is under root now, then here also you have to put root. Okay, here also you have to put root. That's it. Okay, so this is something that's important. And any other thing? Actually, in the case of differentiation, what you have to do is first you have to simplify the equation, then you have to start a differentiation. Then only it will be very easy for all of us. All of us, in sense, for me, for you, everyone who are doing sums. Okay, so let's solve some questions, then some concepts, then some questions, then some concepts. Okay, so I don't know will I be able to solve questions or not in this video, but I've got some questions and also some other concepts, and this is not neat, and this is not neat, and this is not neat. But I'm not going to erase it because it is very important. Okay. Then questions at present we will leave some. Then if I have time now because I have to eat dinner, then I have to go somewhere. Okay, so we will see. I will try to add that. Okay, so next is theorems of differentiation. Van der Waals bond is being created between my hand and the board that causes this shake. Okay, so theorems of differentiation. Composite function theorem also we have. So when y is equal to k f of x, that means when y is equal to constant, y is equal to a constant into a function, that means what can we say? Constant. This question is there in our book also. Log 2 into cos x. What will you differentiate it? Well, for this is where you have to see. Okay, this is where you have to see. This is equal to dy by dx. Okay, when you are differentiating, it will be dy by dx of k into f dash x. Okay, that means you have to leave this constant. Do not touch that constant at all when you are having something like in this form. Just differentiate that particular function that you have got. Okay, here constant is not a function. Okay, constant also we have, constant polynomial like that at all we have. Constant function also we have. Okay, but not like that. Okay, just differentiate this one. Okay, just differentiate this one, which is f of x alone. You have to differentiate. Here, this is what the f of x is. This is a constant, so leave that. Do not touch it. So the differentiation of this is going to be what? Minus log 2 into sin x. Okay, minus log 2 into sin x. Note, I only said that you cannot give the input as negative. The input only cannot be negative. Okay, but this total output can be negative. That's not in our hand. Okay, that is in the hand of those who have created us, those who have created us, those who have created the question paper. Okay, so that is a very good example. Many people do mistake over there. Okay, and also they get doubt over there. Next is y is equal to f of x plus or minus g of x. So differentiation of dy by dx is going to be just differentiate those. Okay, just differentiate those. Nothing is there. Okay, so when you are having like this, so it is going to be f dash of x plus or minus g dash of x. For an example, you are having something like this, like sin theta plus cos theta. then do not think anything, just differentiate it, okay? But here I'll take yes, then in parametric form I'll take beta. Okay, so sin x plus cos x. So just as I said, just merely differentiate. Okay, so what is this? This is going to be cos x minus, this is going to be minus sin x. Okay, so minus sin x. Okay, so this is what the differentiation is. Okay, if in case here minus was there, then here plus will be. If here minus is there, then here plus will be there. Okay, then product rule and division rule are very important. Y is equal to f of x into g of x, like this it is. It is not composite function, it is just product of two different functions, that's it. Okay, then you will also have y is equal to f of x divided by g of x. Okay, then along with composite function you will complete this video. Then in the next video we'll be discussing sums, then some other, all those types, everything. Okay, because I have to eat, then I have to do some sums, then I have to prepare for the examination, then I have to go out. So it is going to be dy by dx is equal to, how will you differentiate it? First you have to differentiate this one, so which will be f dash x into g of x plus g dash x into fx. Some people also say this dash s prime. Okay, so f prime x into g of x plus g prime x into f of x. Okay, like the process some people pronounce it, there is no problem with that. Okay, so here dy by dx is equal to, here how you have to do is, first you have to differentiate the numerator. So f dash x into g of x minus f of x into g dash x whole divided by g of x the whole square. Okay, so this is what the formula is. Then the composite functions. Set derivatives. So you are having something like this, which is y is equal to f of g of h of x. Okay, so what you have to do in this case is differentiate it from the outside, okay, and write the inside. That is your notation. That should be the notation. Differentiate it from the outside and write also the inside. That should be your notation. That means, for an example, like this you are having. So the differentiation of this will be dy by dx is equal to, first differentiate this f. So f dash of, then write the inside. Okay, so g of h of x. Okay, then multiply it, then do the same thing for the next function. Okay, so next function is g of h of x. Okay, so here g dash. Okay, for this you have to differentiate. So g dash of h of x. Okay, then again multiply. Now you can write h. Okay, h dash of x. Okay, h dash of x. Okay, so this is what your thing is. So for an example, if you want, I will give you some. Okay, this is actually, mostly they will not give you 3. If they have given you 3, then use it. Then for 2 now, then y is equal to f of g of x. Okay, so y is equal to, then dy by dx. dy by dx is equal to f dash of gx into g dash x. That's it. Okay, we will do one sum, then you will be understanding this. That is, what sum shall we take? Y is equal to, okay, so y is equal to sine of log x. See, remember here, generally, very generally, it will be to the base of e. Okay, generally it will be to the base of e. If it is not to the base of e, then they will be given, that will be given in the question itself. Okay, that will be given in the question itself. So so what is this signs up? Okay, it is going to be cos of this, you have to write as such. So it will be log x into, okay, into this log x you have to differentiate. What is log x? See, I have said there also, now also I will be saying, which is log x differentiation is going to be 1 by x. Okay, which is going to be 1 by x. And log differentiation with a different base. So a x by dx is going to be 1 by, okay, 1 by log a into x. Correct? Wait, I will check it for the time. Where are you? Okay. So you can ask me a question. Here k is there, here x is there. How is it possible? It is possible when this k is equal to x. That means here it should be x. Okay, it should be equal to x. Okay, and here it is natural logarithm. Here it is natural logarithm. So which means what? Literally everything is literally here. This is also natural logarithm. This is also a natural logarithm. If something is given in common logarithm, then the differentiation will convert it into natural logarithm. If something is given in natural logarithm, it will be converted into just the variables. Okay, that means just the inside. That's it. Okay. So that's it. Okay, so you can write it as cos of log x whole divided by x. Okay, so we have completed till now. By the way, log of e, okay, log e, you might use it. Okay, log of e to the base of e is going to be 1. Log of a to the base of a is equal to 1. Anything when base and the input are same, then it is going to give you 1. I know you will not be seeing relations and functions again. Okay, if you have already watched it, or if you know that concept already well done, then you will not go and see just for logarithmic functions. So that is why this question you will get. Okay, this in one question you will be using it in the entire differentiation and the continuity concept itself. So I said it here even. Then yeah, so that's it for today's video. We will be meeting in another amazing video. Till then, bye bye.